So now we are going to look at flag register. See, accumulator is the default register in which it is having all the flags. We are having 5 flags. All the status of the flags can be known by reading the accumulator. Now that accumulator is also known as program status word, PSW. We can also set PSW. We'll look at that later. Firstly, we are going to look what all flags are present in 8085. So we are having 5 flags which are placed like this: S, Z, then this is don't care, auxiliary carry, don't care, parity, don't care, and carry. So basically we are having 5 flags, and since you know accumulator is having, it's a 8-bit long register. That is why this is how the 5 flags are placed. Okay, SZX, ACX, PX, CY. Okay, now this is the sign flag. Sign flag holds the MSB of the result. This is going to hold the MSB of result. If MSB is 1, that is, if it is a negative number, the sign flag is going to be 1. If it is a positive number, that is MSB is 0, then the sign flag is going to be 0. This is the 0 flag. 0 flag is 1 if result is 1. This is 1 if result is 0. So if you are performing some addition or subtraction such that result is 0, the 0 flag is going to show 1. Then this is don't care. So generally we consider don't care as 0 only, but in any case we know that don't care means you consider 0 or 1, it does not matter. This is auxiliary carry. Since you know that all the registers in 8085 are 8-bit, so whenever you're performing a 8-bit addition operation, 8-bit subtraction operation, if a carry occurs from lower 4 bits to upper 4 bits, then that carry is known as auxiliary carry. We can see an example to understand auxiliary carry first. Suppose we are adding 2 numbers, 27 plus FA. So I'm just representing these numbers in binary first. This 27 can be written as 7 is, FA can be written as. Now I'm performing their addition. So what happens is 1 and 0 is 1. 1, 1 is going to be 0 with carry of 1. 1, 1 is again going to be 0 with carry of 1. This is again 0. Now see, this carry that occurred from lower 4 bits to upper 4 bits, higher 4 bits, this is known as auxiliary carry. This is auxiliary carry, that carry that occurs from lower 4 bits to higher 4 bits. So if in any operation, if this carry occurs, this is known as auxiliary carry. If this occurs, this flag is going to be set, this flag is going to be 1. Okay, fine, let's just complete this. So 1, 0 is again going to be 1, 0, 1 is going to be 0, 1. This is going to be 1, 1, 0, 1, 0 and a carry of 1. So let us just look at all the flags. Okay, first we can look at the flags, then we'll see what will be the status of the flags for this given example. This is the example, what is going to be the status of the flags. So auxiliary carry, this flag is going to be set. This flag is going to be 1, 1. If there is a carry, from lower 4 bits to upper 4 bits. Like in this case, if a carry occurs like this, then this is known as auxiliary carry. Then this P is the parity flag. This is the parity flag. See, there is a concept in electronics of parity. What does this signify is, if there are even number of ones in the result, then that is known as even parity. If there are odd number of ones in the result, then it is known as odd parity. So this flag is going to be 1. this flag is 1. If parity is even means if there are even ones in result, fine. This is the parity flag. Then this one is the carry flag, and obviously from the name itself we know that this flag will be set if a carry occurs. This is one if carry occurs in the result, So we're going to look at the status of this flag register for the operation that we have just performed. We're going to look at it one by one. So sign flag for this result is, MSB of the result. Here MSB is 0, so sign flag is going to be 0. 0 flag is going to be 0. Since the result is not 0, this is going to be 0. Then we have don't care, we take it as 0. Auxiliary carry has occurred, so auxiliary carry flag is going to be 1. Again we have don't care. Then we have parity. We are going to count the number of ones in the result. See, number of ones in the result is 2, which means even parity. So parity flag is going to be 1. Again we have don't care. And since carry has occurred, so this flag is going to be 1. So just see what number is it in hexadecimal. So this is 15. So the flag register, the value of this PSW after execution of this result in microprocessor is going to be 15. This is how you can find the value of your flag register after any arithmetic operation. We're going to take another example for this. So suppose A register is holding a value 0, 1 and register B is holding a value FF. And we perform an instruction, we are giving an instruction add B. Now first of all let us look at what does this instruction do. The function of this instruction is to add the contents of B to the contents of accumulator, and the result is going to be stored in the accumulator itself. Okay, one more thing, the status of the flag registers, the values of flag registers are going to be determined based on the values of accumulator. Okay, we are going, flag register can only be set, its value can only be changed according to the contents of the accumulator only. Fine. So let us just perform the operation first. A is holding this value 0, 1. See, this 0, 1 was in hexadecimal. I just converted into binary first. Contents of B are FF, which are 1111, 1111. I'm just going to add. See, the instruction is add B. So what happens is contents of B are going to be added to contents of accumulator, and the result is going to be stored finally in the accumulator. So when I add 1, 1, this is going to be 0, 0, 0. So we've got an auxiliary carry, but again 0. So see, finally contents of the accumulator. Okay, after this instruction contents of B are not going to change. Okay, the register B is untouched. Contents of accumulator are going to be overwritten with the result, which is 0. Now just have a look at all the flags. What is going to happen to all the flags? Let us see. Sign flag is set when MSB of the result is 1, MSB of the result is 0, so this is going to be 0. 0 flag is going to be set because the final result is 0, then this flag is going to be 1. This is don't care. Auxiliary carry was present, so we going to make this 1. This is 0. Parity, see, there are 0 number of ones, or we can say even number of ones present in the result, so this is even parity. This is going to be 1, 0, and since a carry has occurred, this is going to be 1. So as you read this number, you just read this number what it is. So if I want to write this number in hexadecimal, it's going to be 55H. So this is going to be the value of the flag register after execution of this arithmetic operation. Okay, so generally if they are asking questions from this topic, what they are going to do is they are going to give you a question similar to this. They are going to give you contents of 2 registers, they are going to give you the instruction, and then they are asking the values of the flag register, or they are giving the value of flag register initially, and after execution of an instruction they are going to ask what is going to be the final value of the flag register. So we are going to look at one more question from this module, then we'll see another topic after that. So we are given a question, now we are looking at one more question. Initially flag register was holding the value, contents of flag register were 55. Accumulator or register A was holding the value 03 and register E was holding the value 27. Now we are performing an instruction ADCE. What is instruction is going to do is, this instruction is add with carry. This ADC means add with carry. So what this does is, this is going to add the contents of register E to contents of register A along with the carry. So when we are trying to add with the carry, first we need to know the present status of the carry. We need to know that whether carry is 1 or 0. So where does we get this information from is from the contents of this flag register. You already know that the flag register is SZX, ACX, PX, CY. They've also given the contents of flag register, just put them. So from here we see that initially carry was 1. Okay, so what they're asking is, they're asking the final value of flag register. What is going to be stored in the flag register, they're asking. So we see from here that initially carry was 1. So what you're going to do is, you're going to add the contents of A which is holding 0, 3 with contents of E which is holding 2, 7 along with the carry. Carry initially is 1, so we are going to add a 1. We just start with this addition. So this is going to become 1 with the carry of 1, again 1, 1, 0, 1, 1. See, now there is no auxiliary carries, okay. We are not getting any carry from lower 4 bits to upper 4 bits, so auxiliary carry is going to be 0. So final contents of register A are going to be 0, 0, 1, 0, 1, 0, 1, 1. Okay, fine. Now we're just going to look at the status of the flag register. SZX, ACX, PX, CY. Just going to look. MSB of the result is 0, so the sign flag is going to be 0. The result is not 0, so 0 flag is 0. Don't care, we considering 0. Auxiliary carry was not present, so this is also 0. Again, don't care. Now see, number of ones, 1, 2, 3, 4, 4, which is even. So parity flag is going to be 1. This is again, don't care, 0. And there was no carry present, so this is going to be 0. So finally, what is going to be the content of flag register? 04H. So this is what they are asking. They're going to ask you some questions like that. So what you need to remember is what all flags this 8085 is having. It is having a sign flag, 0 flag, auxiliary carry flag, parity flag and carry flag. How they are placed? They are placed in this order: SZX, ACX, PX, CY, and when which flag is going to be set and which flag is going to be reset. This is all you need to remember. After you have studied all the instruction, you can just see from the value of accumulator which flag is going to be set and which is going to be reset. So this is how you're going to attempt the questions from flag register. Then there are some operations that we can perform on this PSW, and we can also read the status of this PSW. We've got some instruction. We're going to look them together in the instruction set. Okay.